Hi, this is Ms. Park. This lesson is on linear systems word problems. Okay, so by now you should already be familiar with solving a linear system, which is two lines at the same time, using the methods of graphing, substitution, and elimination. So in this lesson, I'm only going to show you how to set up the word problems, and we won't solve them. We'll just assume that you know how to do the solution. Okay, I will solve the very first one only. So first we have a simple number problem, and it goes like this. The sum of two numbers is 49. Their difference is 11. Determine the numbers. Okay, we're going to have two variables, one that represents the first number and one that represents the second. And then we're going to set up two equations. So very important that when we use a variable, we make this let statement. So a let statement introduces the variable. It means I'm going to start working with the variable, but here I'm going to say what the variable means. So over here, they've done it for us. Let x and y represent the numbers. So my first equation, the sum of two numbers is 49, means that they add up to 49. So that's my equation. And my second one is their difference is 11. That means if you take one of them and subtract the other one, you get 11. That's my second one. All right, and now you can choose to solve this by elimination or substitution. Actually, substitution is nice because it's easy to isolate a variable, but I'll do elimination. I'm going to try and isolate the x's, and I get x minus x, so I have no x's, so I won't write it. Y minus negative y, that's the same as y plus y, so that's 2y. 49 minus 11 is 38. Now I solve this, divide by 2, 38 divided by 2, y equals 19. So that's one of my numbers is 19. Then I can take my 19, in sub y equals 19 into one of the equations. So maybe I'll go equation 1. X plus 19 equals 49. X equals 49 minus 19. X equals 30. Okay. So when you learn to substitution or elimination, you just started with the equations and ended up with the solution. Okay. In word problems, we have to first introduce the variables, then do the solution, and then we must answer the question. The question said, determine the numbers. So we're not done until we answer that. So we have a therefore statement, a concluding statement, and it says, therefore, the numbers are 19 and 30. Okay, and that is a complete solution to a word problem. So now I'm going to just help you set up the other word problems. So money problems, it looks like this. Bob has a total of $425, all in $20 bills and $5 bills. He has a total of 31 bills. How many $20 bills does he have? Okay, this says let X represent the number of $20 bills and Y represent the number of $5 bills. I'm actually going to change the variables. I don't love X and Y for word problems because X and Y don't have meaning to us. But if I take my $20 bills and call it a T, T for 20, and then the $5 bills, I'll use an F, F for 5, then when I'm working with T's and F's, when I get my solution, I'll know what they represent. Okay, so he has a total of $425 and he has a total of 31 bills. So we know that the number of $20 bills plus the number of $5 bills, we know that that's 31. Okay, so that equation had to do with the number of bills. So I'm just going to put that over here. But now the next equation is going to have to do with the dollar value of the bills. Okay, we know that there is a total dollar value of $425. So how do we fill in the rest? If he has T $20 bills, how many dollars is that worth? Right? If he has one $20 bill, it's worth $20. If he has two $20 bills, that's $40. If he has 10 $20 bills, that's $200. So what are we doing? We're multiplying the number of bills by 20. So if he has T $20 bills, then that's worth 20T Same thing with the F. If he has F $5 bills, each one is worth $5. So altogether, F $5 bills is worth 5F dollars. And that's our equation 2. So one has one is the number of bills and the other one is the dollar value. If you look at these two equations, they can be solved with elimination. You would just have to multiply the top equation by some number to isolate the variable, to be able to eliminate a variable. So probably if I multiply the top one by 5, I would have 5t plus 5f equals 155, and then the bottom one could stay the same and you can use elimination. The important thing is that we have a let statement up here, and then at the end, we're going to say, therefore, Bob has, and then you'll fill it in whatever number of $5 bills and whatever number of $20 bills. Okay, so I'm not going to do it. You can do it. Okay, and that's your answer. And really, it says how many $20 bills does he have? They didn't ask you how many $5 bills, so you don't actually have to answer that part in the therefore statement. Okay, let's do another one. So distance, speed, and time problems. Okay, so Sam traveled from Winnipeg to Calgary, a distance of 1,210 kilometers, partly by train and partly by bus. The train travels at 90 kilometers per hour, and the bus travels at 80 kilometers per hour. If the total trip takes 14 hours, how far did he travel by train? Okay, so let's fill in this chart. So often a chart will help you to organize the information in the word problem. So we know that he traveled from Winnipeg to Calgary. Okay, the total distance is 1,210, and some of it by train and some by bus. So in the chart where there's total distance, I can put it in over here. Then they also says the train travels at 90 kilometers per hour, so I can put that in for the speed. So this is kilometers per hour, this is kilometers, and this is hours. Okay, and then the bus travels at 80 kilometers per hour. And I want to set up some equations with x and y. Okay, the other thing we know that we didn't use yet, okay, so I've used this, I've used the 80 and I've used the 90, and the last thing I haven't used is the 14 hours. So the 14 hours goes in the time column. Okay, so the total time is 14 hours. We're almost filled in the entire chart. I can see that in the time column, I'm going to have an equation that says x plus y equals 14. Okay, what they've done is they've made the variable the time that it takes by train and the time that it takes by bus. So those are our two variables. If you're defining them in a chart, you don't need a let statement. You need either a let statement or a chart. Okay, so I'm going to put over here let statement or a chart. So you could have said, let x represent the number of hours by train, let y represent the number of hours by bus. But here they're doing it in a chart, so you don't need the let statement. We need one more equation that has to do with the distance, because we know the total distance is 1210. So what's going to go over here? So in the bubble here, it tells you, remember, distance equals speed times time. You may have seen this in maybe science class somewhere. It's this little triangle, D and an S and a T. It's the relationship between distance, speed, and time. If you cover up the S, you get speed equals, and then you can see a D on top and then a T, distance divided by time. If you cover up the T, you see that time equals distance divided by speed. Now, if you cover up the D, the distance, you see that distance is equal to speed times time. They sit one beside the other. So if I know the speed is if I want to figure out this distance over here, that is speed times time, so that is 90x. And distance by bus is going to be 80y. And that's going to tell me the rest of the equation. So I can see that 90x plus 80y is equal to 1210. All right, and there you have your two equations, and you can solve those by elimination and make sure that you answer with a therefore statement. Therefore, he traveled so many kilometers by bus and so many kilometers by train. Make sure that you have units in your final answer. Okay, the last type of problem is called an H problem. Okay, so Sue is 6 years older than Joe. 4 years ago, she was twice as old as Joe was. How old is Joe now? Okay, so let's take a look at this. They've already started with the let statement. I'm actually going to take it out. If we're going to use variables, let's use S and J. Be careful with S. It can't look like a 5. So you got to make it like really curly so it doesn't look like a 5. Okay, so Sue is X years old now, so we're gonna say S, and then Joe is J. 4 years ago, Sue was S minus 4 years old, and Joe was J minus 4 years old. Okay, right now, Sue is 6 years older than Joe. So our first equation is from now, Sue is 6 years older than Joe. Means Joe's age plus 6 gives you Sue's age. That's equation 1. 4 years ago, so that's using equation 1 uses the now column. 4 years ago, she was twice as old as Joe was. So 4 years ago, Sue was twice as old. Sorry, I'm using the wrong age for her. Okay, so let's do this again. So 4 years ago, we're going to use the numbers from the 4 years ago column. Sue was twice as old as Joe was. And that's equation 2. Okay, and then here you're going to have to expand and you simplify the equation and then line up the variables and decide if you want substitution or elimination. I lied, there is one more. Percentage problem. Jennifer invested $500 into 2 different investment plans. The first pays interest at 7% per annum. So per annum means per year. The second plan pays interest at 10% per annum. That's per year. After 1 year, the total interest she made was $44. How much did she invest into each plan? Okay, so a little bit tricky with the money here, but basically when you put money in a savings, it earns interest. It means you earn some money back. And so a percentage of the money that you put in, the bank will give you to keep, and that's called interest. So there's a lot of information given in this question, but really there's 2 types of information. There's about the total money that she has that she's put into the investment, and there's about the interest that she has earned. We can see that the total money that she puts in is $500, and we don't know how much she's put into the first plan and how much she's put into the second. So they've started it for us. They said let X represent the amount invested at 7%, that's the first plan, and Y is the amount invested at 10%, that's the second plan. So we have one equation that it has to do with the total amount of money she put in. She put X dollars into the first plan and Y dollars into the second plan, and that's equation 1. It has nothing to do with the interest rate. The second equation is going to have to do with the interest rate. If she puts X dollars into an account and earns 7% interest on that, she will have 7% of X earned in interest. Same thing with the other one. She would have 10% of Y earned in interest. Okay, the amount of money she puts in the first account is going to get 7%. The amount of money she puts in the second account is going to get 10%. So that's how you calculate 7% of a number and 10% of a number. And then they say that the total interest that she made, so from the 2 accounts, the total interest is $44. And that's equation 2. So once again, these are your 2 equations. You will have to solve them by substitution or elimination, your choice. Don't forget to answer the therefore statement. She invested this much money into the first plan and this much money into the second plan. Okay, so now you have all the different types of word problems that we'll be covering. Please practice, and thanks for watching.